Yeah, hi everyone, welcome to PrepFusion. So, people have been preparing for MS Tech interview, and I hope you guys are following our Tech Master 3.0. Okay, Tech Masters 3.0. I hope you guys are following it. But one question I am receiving again and again in DM. Those who are preparing for GATE examination and those who are done with the network analysis, they can also see this question. Okay, so this kind of question I am receiving again and again in the DM that sir, what will be V naught waveform? Some are saying we will apply superposition theorem, this or that, and this question also I am receiving. Okay, so we will solve both of the questions. You can try on your own. You need to draw the V naught waveform. Understandable? Okay, this is a easy question and this is a good question. But these kind of questions are there in our class notes. Okay, in test series, I guess we have framed the same kind of problem in test series. Ditto same kind of question is there. But still the doubt is coming by a lot of people. So I thought that I can make a separate video. Now some are saying we will apply superposition theorem. But did you notice one thing? Two voltage sources are there. This voltage source is there. This voltage source is there. Both are same. No. This is step 3 ut. This is a step function. This is a step voltage and this is a DC voltage. If I call this voltage source as V1 and I call this voltage source as V2, so can I draw the waveform of V1 and V2? V1 is simply the DC while V2 is the step. I hope you understand the difference between both of them. V1 is simply 5 volt. There you go. This is your V1. 5 volt. Always it is 5 volt. It is starting from t equals to minus infinity. It is 5 volt from t equals to minus infinity. It is always 5 volt. But what about V2? At t equals to minus infinity, it is 0. But at t equals to 0 plus, it has become 3 volt. So this is applied at t equals to 0 plus, right? So this is the difference between V1 and V2. So whenever we analyze the circuit, we analyze it with the all initial condition. That means I will analyze the circuit from t equals to minus infinity to t equals to plus infinity. So I need to get started with t equals to minus infinity. People are starting from t equals to 0. Why is that so? No matter whichever the circuit is given, always start it from t equals to minus infinity. Whether it is network analysis or analog electronics, always start from t equals to minus infinity. So we will be getting started with t equals to minus infinity. So let's see what will be our circuit from t equals to minus infinity to t equals to 0 minus. From minus infinity to 0 minus, what kind of circuit we will be getting? So let's see the circuit. So sir, it will be the same, but the point is that this step function will not be present. What will not be present? The step function will not be present because V2 value will be 0. But in this window, in this particular window, this V2 value will be 0. So sir, this value will be 0. That means here the voltage will be 0. Right? So this is the scenario from t equals to minus infinity to 0 minus. So if I analyze at t equals to minus infinity, at t equals to minus infinity, what will happen? Voltage, let's call this as Vc. Okay, this voltage I am calling as Vc. This is the voltage at Vc. Okay, so let me know one thing. At t equals to minus infinity, what will be the Vc voltage? Is there any impulsive current? Can you find out the current at t equals to minus infinity? So that would be capacitor will have 0 voltage, so 5 by R. Current will be 5 by R. Is this current impulsive? No. If this current is not impulsive, that means it will hold its initial voltage, which is 0 only. So it will be 0. If there is no impulsive current, that means there will not be any instantaneous change in the voltage. So what will be the voltage? 0 volt only. And what will happen at the steady state? At the steady state, what will happen? At the steady state, this will be open circuited. I am talking about 0 minus. So it will be open circuited. If it is open circuited, then there will not be any current here. So V naught value will be 0. So circuit will look somewhat like this. This is grounded. This is the resistance R. This is open circuited. I hope you know the concept of impulsive current and all those things. If you are preparing for interviews in a good manner, then you would know the meaning of all these things. If you are studying from good educators, then I cannot do anything. This is resistance R. So what will be the scenario here? This voltage will be 5 and from here 0 voltage will come. So capacitor will be charged for 5 volt in this direction. 5 volt in the opposite direction. So Vc at 0 minus will be minus 5 volt because you see the polarity up to down, but it is being charged from down to up. So it will be charged to 5 volt. So Vc 0 minus will be minus 5 volt. And what about V naught? So can you let me know the value of V naught at 0, V naught at minus infinity? What that value will be? At minus infinity, what will be the scenario? At minus infinity, the capacitor will be short circuited. So this value will be 0 and this value will be 5, right? Because capacitor is short circuited, no? So V naught of minus infinity will be 5 And what will be V naught of 0 minus? At 0 minus, what will happen? Capacitor will be open circuited. So 0 voltage will come from here. So it will become 0. Basically, what is your V naught? V naught is nothing but V1 plus Vc. So what is V1? 5. What is Vc here? 0. So 5 plus 0 will be 5 volt. What is V1 here? 5. What is Vc here? Minus 5. 5 minus 5 will be 0. It is very simple. Very straightforward. So this is the analysis we have done from t equals to minus infinity to 0 minus. Our matter of concern will be only 0 minus, not minus infinity. Minus infinity will never be matter of concern. So let me draw the waveform. So we are drawing two waveforms, Vc and V naught. Okay, just one second. Yeah, so two waveform, Vc and V naught. So started with Vc at t equals to minus infinity. What was the scenario? This was uncharged. It was at 0 volt, right? And then it became to minus 5. So our matter of concern is this minus 5 voltage only, nothing else. So here I will draw only the minus 5 voltage. This voltage I will draw. 0 minus means this is the steady state. Okay, 0 minus means this is steady state I am talking about. 0 minus simply means steady state here. This is steady state and this is the initial condition. This is initial and this is steady state. Right, from here circuit started and this is the steady state. Although it was at 0 and then from 0 to minus 5 volt it would have reached. So it would have reached somewhat like this, exponential charging. But I don't need to make this waveform. I don't need to start it from minus infinity. I will just simply show that here the value is minus 5 volt. Right, and what about V naught? V naught was 5 volt only. Why 5 volt? Because this capacitor was shorted, so this 5 volt was reached here. So V naught was 5 volt. And at 0 minus what it became? Since it became open circuit, at 0 minus it became open circuit, then what really happened? It became open circuit. So from here there was no current. So across the resistor there was 0 voltage drop. So V naught became 0. So from 5 to 0 it came. From 5 to 0 it came. So it came somewhat like this. But what we need to show? We only need to show the circuit at t equals to 0 minus. At t equals to 0 minus you will have 0 voltage. Although it came somewhat like this from 5 to 0. But I don't need to show this waveform. I just only need to show this 0 volt, which is 0 volt. Okay. Now let's see what will happen at t greater than 0. At t greater than 0 what will happen? So what do you think? What will happen in the circuit at t greater than 0? So this is our circuit, which I will copy and paste it here. So at t greater than 0 now, greater than equals to 0, this 3 volt also has come into action. Forget about this V2. This 3 volt also has come into action. Now 3 volt also has come into action and 5 volt is also there into action. Along with that, the capacitor is having some initial voltage as well. Capacitor is having some initial voltage of minus 5 volt as well. Initial voltage of minus 5 as well. Are you able to understand this point? This is our Vc, no? So it is having initial voltage of 5 volt in the opposite direction. Now let's see at t equals to 0 plus what will be the current. At t equals to 0, or you can say it at t equals to, I should say at t equals to 0, what will be the current? So this is your 5 volt and this is having minus 5 voltage. So I am assuming that capacitor is holding its voltage. So this is 5 and this is minus 5, this voltage will be 0. This is plus 5 and this is minus 5. So 5 minus 5, what that would be? This voltage will be 0 and this voltage is 3 volt. So 3 volt here, 0 volt here. So how much current it will be driving? 3 by R. Now this 3 by R current will be charging this capacitor. So current is 3 by R. Is it impulsive? Not impulsive. Since it is not impulsive, what does that mean? That means capacitor will hold its voltage. That means the assumption that we made that capacitor is holding its voltage. So Vc0 minus will be equals to Vc0 plus and that will be equals to nothing but minus 5 volt only. Is that clear to you? So capacitor is holding its voltage, there is no impulsive current, so it is a very simple circuit. So let me know what will be the value of Vc infinity. So at infinity what will happen? This capacitor will become open circuit. So what will be the circuitry at infinity? So at infinity the scenario will be, this will become open circuit, right? This will be the scenario at infinity, that this has become open circuit. So since this has become open circuit, then what will happen? Here there will be 0 voltage drop. So this 3 volt will come here and 5 volt will come here. So 5 volt here, 3 volt here. That means Vc value will be nothing but minus 2 volt. Are you able to understand this point? 5 volt here and 3 volt here. But Vc value is taken from up to down. That means 3 volt to 5 volt. So how much drop is there? Minus 2 volt. So Vc infinity will become minus 2 volt. And let's talk about V naught. So V naught at 0 minus will be equals to V naught at 0 plus only, because Vc value is not changing. 5 volt is also not changing, VC value is also not changing, then V naught will also not change instantaneously. So it will be equals to, what was the value here? 0 volt only. So it will be 0 volt only. And what will be V naught infinity? V naught infinity, you can directly see that 3 volt is coming here. So V naught infinity will be 3 volt. There you go. Very simple thing. First order circuit, exponential charging would be there. So V naught will go from 0 to 3 volt. Right? V naught will go from 0 to 3 volt. And VC is going from minus 5 to minus 2 volt. Minus 5 to minus 2 volt. So this was the easier one. Okay, I just wanted to tell you the meaning of DC voltage and step voltage. Next question would be good. So I hope you guys will be solving that. Okay. So here there is not a big matter of concern. No? Why there is? If you just make the VC waveform, then V naught waveform will be a cakewalk. Or if you make V naught waveform, then VC waveform will be a cakewalk. Why is that so? Because what is V naught? V naught is simply VC plus V1. What is your V naught? V naught is simply VCT plus V1. And what is V1? V1 is nothing but 5 volt. So if you shift this waveform by 5 volt upward, if you shift this waveform by 5 volt upward, you will get this waveform only. Because what is minus 5 plus 5? That is 0. What is minus 2 plus 5? That is 3. That's it. Okay, so just shift this waveform upward and you will get the answer. Shift this waveform upward, you will get the answer. Right? Or if you are able to make this waveform, then what you can do? VCT will be nothing but V naught T minus 5. So shift this waveform by 5 downward. So 0 will become minus 5 and 3 will become minus 2. There you go. Okay. So that's the answer. Very straightforward question. This was very easy. Try solving this one. Here the concept of impulsive current will come into action. Again, this is DC. Sorry, yeah, this is DC and this is step. So where will you start from? You will start from minus infinity. Whatever that happens at minus infinity, that is not a matter of concern. Matter of concern is 0 minus, because I know that I need to make my waveform from here, from 0 minus. So whatever that happens at minus infinity, although you can also tell what will be the voltage at minus infinity, but big matter of concern will be not minus infinity, it will be 0 minus. Although we will see at minus infinity as well, but yeah, so we will copy the circuit here. So what will be your circuit in this window? In which window? In this window, what will be your circuit? So in this window, this will be gone. Step will not be there. So this will be gone. And this will be available. So at minus infinity, what will happen? Let's call this as VC1 and this as VC2. So at minus infinity, what will happen? Minus infinity, that means starting of the circuit. Both will be shorted. And if the whole circuit is shorted, there will be impulsive current. Like this will be the scenario, no? Capacitor. This capacitor will also be shorted. This is a resistance. Then there is another capacitor. This is also shorted, and here there is 5 volt. So whole circuit is shorted. So how much current will be there? 5 by 0. That means infinity current would be there. Infinity current means impulsive current would be there. That means there will be instantaneous charging. So instantaneous charging, how it will take place? Voltage is always divided in the inverse proportion. Right? Q equals to CV. So voltage will be always inverse proportion of the capacitor. Right? So voltage will always be divided in the inverse proportion. So if you need to write down the value of, let's take the VC1 and VC2 in this direction. Okay, this time I am taking VC1 in this direction. Please note, this is our VC1 and this is our VC2. So for the ease of the calculation, nothing else. This is how I am taking VC1 and VC2. So VC1 at minus infinity. Although it is not a matter of concern, still I am writing down so that you can revise it. So what that would be? 2C upon 2C plus C. 3C multiply with 5 volt. So that will be 10 by 3 volt. And what will be your VC2 at minus infinity? That will be C upon 3C. Multiply with 5 volt. So that would be 5 by 3 volt. Right? Now what will happen at 0 minus? At 0 minus, this will be open circuited. This will also be open circuited. Right? Because at steady state, capacitor will not drive any current. So this will be open circuited. This will also be open circuited. So make the circuit at t equals to 0 minus. At t equals to 0 minus, what will be the circuitry? So this was already not there. This will become open circuited. And this will also become open circuited. And this was already grounded. Now whole circuit is open circuit. Look, will there be any current through the resistor? No, 0 ampere current would be there. That means this will take 0 voltage drop. This will take 0 voltage drop. So this is 0, this is taking 0 voltage drop, so V0 will also become 0. This is at 0 minus. Okay, just 1 second again. थोड़ा सा जुकाम है यार, इसलिए बार बार पोज करना पड़ रहा है बीच में. ठीक है, ये 0 वोल्ट हो गया. दिस इज 0 वोल्ट एंड दिस इज ऑल्सो 0 वोल्ट, सो दिस विल ऑल्सो बी 0 वोल्ट, राइट? So can you let me know what was our VC? This was our VC2, right? VC2, and this was our VC1. This was our VC1. So can you let me know what will be the value of VC2 at 0 minus? What that value will be? VC2 at 0 minus. 0 voltage drop is there, so it is 0 volt only. And what will be the value of VC1 at 0 minus? Look, in the whole circuit there is 0 current, right? So this is 5 volt and this 0 volt has reached here. So this is 0 volt and this is 5 volt. Notice the direction from down to up. So this will be 5 volt only. Say yes or no? 5 volt only. Understandable? So at 0 minus we have analyzed the circuit. So they will carry their condition, and we can analyze the circuit of a V0 of 0 minus as well. So what will be the value of V0 of 0 minus? That will be 0 volt only. And here minus infinity is not a matter of concern, but you can write down, if VC1 at minus infinity is 10 by 3 volt, then what will be your V0 1 at minus infinity? That would be simply, sir, this is 0 plus VC2, so that would be simply equals to VC2 only. That will be 5 by 3 volt. Basically at minus infinity this is charged to 5 by 3 volt. So this voltage is 0, then this voltage will be 0 plus 5 by 3. If this is 0 and this is 5 by 3, so this will be 0 plus 5 by 3. So this will be 5 by 3 volt only. But V0 is not a matter of concern for us. V0 at minus infinity is not a matter of concern. Always matter of concern are these three values. Say yes or no. Okay. So at 0 minus we have analyzed the circuit and we will put all the values. So we will draw the waveform of VC1, we will draw the waveform of VC2, and we will draw the V0 waveform as well. Okay, so VC1, VC2 and V0 with respect to time. So in the interview as well, you need to take care of 0 minus only, not minus infinity. Okay, so VC2 was 0, this was also 0, and this was 5. So VC1 was 5 and rest all over 0. So this was 5. So you will show like this, that at steady state this was 5, this was 0, and this was 0. Now the interesting part would come up. Right, now what would come up? T equals to 0 plus would come up. Right, or at T equals to 0. At T equals to 0, what will be the circuitry that we need to draw? Okay, so let's copy our circuit. Now 3 volt is also coming into action. Right, 3 volt is coming into action. 5 volt was already there. Now you let me know what is the initial voltages these capacitors are holding. So this guy is holding 0 volt and this guy is holding 5 volt. In what direction? In this direction. Now you should have the temperament that you can directly start your circuit from here. What you will say? Sir, I need to check the steady state condition at T equals to 0 minus. At T equals to 0 minus, I need to check this condition. So without even drawing the circuit, you would know that, sir, this 3 volt is not there, this is not there. Then, sir, circuit will be completely shorted, capacitor will be open circuited, resistor will have 0 voltage drop. So this will have 0 initial voltage, and since this is having 0 voltage drop, this is also 0, and here there is 5 volt, so the capacitor will have 5 volt. So in the interview, you need to have the temperament that directly you can write down this circuit. That, sir, these are my initial conditions. Now at T equals to 0, can you draw the circuit? How will I draw the circuit? Sir, here there is 3 volt. Or I will copy the circuit simply. This is, sir, 3 volt only. Now this particular capacitor 2C, which is having initial voltage of 0, so this capacitor will be replaced with its initial voltage only. This will be replaced with its initial voltage, which is 0 volt only. Which is 0 volt only. And this capacitor will be replaced with its initial voltage, which is 5 volt. So this is how this will be replaced. Downward plus minus 5 volt. Can you let me know what will be the current in the circuit? What will be the current in the circuit? This is 3 volt. Since this is completely shorted, here 3 volt will come up. This is 3 volt And now this guy is saying that this is 5 and this is minus 5. So one node is saying that this should be 3 volt. And if I go from here, this is 0, this is 5 volt, and this will be minus 5. So 5 minus 5 will be 0 volt. So one node is saying 3 volt, another node is saying 0 volt. What does that mean? This is the condition of infinite current. This is the condition of impulsive current. So either you can check by KCL, KVL, or you can simply see that whole circuit is being shorted, no? If I walk in this loop, then all I see is voltage source and short circuit path. 0, 3 volt, short circuit path, then short circuit path, then plus 5 volt, then minus 5 volt. So in the whole circuit, what is the current that is flowing? At 0. What is the capacitor current, or what is this current? I current is flowing in the circuit at 0. That is impulsive. Impulsive current is flowing. If there is an impulsive current, that means there will be instantaneous change in the capacitor voltage. Instantaneous change in capacitor voltage. One more second. In capacitor voltage. Okay. Now, how do you write down the value of capacitor voltages if there is an instantaneous change? So this concept we have already seen, right? If there is an instantaneous change, so this resistor could be ignored, right? Parallel combination of RC could be replaced with only capacitor. Here only capacitor would be there. Here there is 5 volt. So how will I write down the initial voltages now? I need to write down the voltage across the capacitors at t equals to 0 plus, because there will be instantaneous change now, right? So this I can ignore. Why I can ignore this? I hope you know the reason. Okay, if you have followed switch capacitor circuit, then you would know how I did this particular analysis. Okay, because in switch capacitor circuit we have seen this kind of circuit. Now we need to write down the initial voltages. So this capacitor is having initial voltage of 5 volt in this direction, and this is having 0 volt in this direction, right? And what is the direction we have given? We have given VC1 in this direction. This is our VC1, okay, and VC2 also in this direction only, okay, VC2 also in this direction. So you know that some impulsive current would flow. Now because of this impulsive current, if this guy is developing delta T voltage, I am assuming the direction of current in this direction. This is the direction of current. So if this guy is developing delta V voltage, so how much charge it will develop? 2C delta V, right? So how much voltage this guy needs to develop? This guy needs to develop a 2 delta V voltage, because capacitance value is C and it needs to develop 2 delta V voltage. That's why the charge would be same. Basically, whatever the charge he is developing, he will develop the same charge. Why is that so? Because they are in series. We have seen all these kind of concept, okay? After that, we are solving all these problems. We have seen these kind of concept. If you feel like that, sir, I already know transient analysis, I did not study from Tech Master 3.0, then you are mistaken. Really sorry for that, okay? Because 99% of the GATE aspirant doesn't know a single thing about transient. They will get to know that we don't know transient only in the interview. So if current is flowing, then this is developing delta V voltage, then this will develop 2 delta V voltage, because 2C into delta V, then C into 2 delta V, both should be same. Understandable? So what you can write down, this VC1 was initially 5 volt, but it is developing 2 delta V voltage in the opposite direction. So this will be the voltage of VC1 at t equals to 0 plus. This is the scenario that is going on at t equals to 0 plus. And what about VC2? VC2 was initially having 0, but it is developing minus delta V. It is developing delta V in the opposite direction. You see the VC2 voltage. VC2 voltage is given in this direction, but it is developing delta V in this direction. So what I will write down? Minus delta V. So the scenario is that if I make the circuitry would look somewhat like this at t equals to 0 plus. This is capacitor 2C, this is capacitor C, and then there is another voltage source 5 volt. So this is the scenario we are having. Okay, this is 3 volt, this is 5 volt at t equals to 0 plus I am talking about, and this is 2C, and this is capacitor C. So this has developed delta V here, and if I write down the voltage in this direction, if I am writing down the voltage from up to down, because this has developed delta V, so up to down if I am writing down, then it would be 2 delta V minus 5. 2 delta V minus 5. Did you understand this point? Just opposite I am writing down, no? Polarity I am changing. So this is the scenario at t equals to 0 plus. So using the KVL equation, I can find out the value of delta V. So find out the value of delta V on your own. So can I apply the KVL equation? Yes, sir. Do it on your own. I will again have to take some break because of the cold. Okay. So you write down the value of delta V. So if I apply the KVL equation, it will be simply 2 will be equals to delta V plus, sorry, 3 will be equals to delta V plus 2 delta V minus 5 minus 5. Right? Basically 0, this is plus 3 minus delta V minus 2 delta V plus 5 minus 5. So simply this equation I will get. It's like 3 voltage sources driving this whole circuit. Right? If you jump from here to here, this is a positive sign. When you jump from here to here, this is negative sign, then this is negative sign, and this is negative sign. So this is how I can write down. It's not very difficult for you, right? I hope it is understandable. It is very straightforward and a very easy thing. Understandable? So what is the value of delta V we are getting? Delta V we are getting as 13 by 3 volt. Okay, a kind of not so good value we are getting. 13 by 3. Let me check the KVL equation. So this was developing delta V in this direction, and this was developing 2 delta V, 2C delta V, 2C delta V. This was 5. So 5 was already there in opposite direction. So 2 delta V minus 5. So 3 equals to, this is delta V, 2 delta V minus 5, and then sorry. This will be plus 5. No, sorry guys, sorry. This voltage is plus 5. Basically, I messed up in the KCL KVL equation. So how will I write down the KVL? Starting from 0, this will be plus 3, then minus delta V, then minus sign and this potential. That would be 2 delta V minus 5. Then minus sign this potential. That would be equals to 0. I hope this equation is clear to you. Right? So what I will be getting? 3 minus delta V minus 2 delta V plus 5 minus 5 would be equals to 0. From here delta V I am getting as 1 volt. Right? This is the value of delta V I am getting. Okay. This is the value of delta V I am getting. So I can write down the potential Vc2 and Vc1 at t equals to 0 plus now. So this was the scenario at t equals to 0 plus. So I can write down the potential now. So Vc1 at t equals to 0 plus is coming out to be, delta V is 1, so it is coming out to be 3 volt. And Vc2 at t equals to 0 plus is coming out to be minus 1 volt. And you can check as well. You can check the circuit. This is 3 and this is minus 1. Right? So 3 plus 1, this will become 4. And this is 5 only. And basically, this is delta V only, no? It is coming out to be minus 1. So 3 minus 1, this will become 2 here. And this is 5. And it is being 3. So 5 minus 3, 2. Yes, KCL, KVL, everything is satisfied. So this is the condition we are getting at t equals to 0 plus. So at t equals to 0 plus, Vc 0 plus is coming out to be 3 volt. Vc2 0 plus is coming out to be minus 1 volt. Can you find out V0 plus, V0 at 0 plus now? What will be V0 at 0 plus? So V0 at 0 plus will be nothing but 3 plus Vc2. Because this voltage is 3, this was your V0. Right? This node is V0. So 3 plus Vc2. So 3 plus Vc2, which is minus 1. So that is coming out to be 2 volt. Or you can write down, it would be equals to 5 minus Vc1. 5 minus Vc1. Vc1 is 3. So that will also come out to be 2. So at 0 plus, we have find out the voltage. That was the biggest matter of concern. Okay. If they want to ask a question on, if they want to ask this particular question, that means they are asking you the value at t equals to 0 plus only. So there is a sudden change. 5 has gone down to suddenly to 3. 5 has suddenly gone down to 3. 5 has suddenly gone down to 3 volt here. Okay. For Vc2, 0 has suddenly gone up to minus, sorry, 0 has suddenly gone down to minus 1. And what about V0? It has suddenly gone up to 2 volt. Understandable? Minus 1, and this is 3 volt. Understandable? And now at infinity, you would know that at infinity, capacitor will be open circuited. So at infinity, writing down these voltages are very easy. All these voltage you can write down at infinity very easily. This will be open circuited. This will also be open circuited. Here there is 3 volt. Just notice the polarity. This I consider as Vc2 and this I consider as Vc1. So this 3 volt will come here. So this is the resistor having 0 voltage drop. So this is 5 volt Just 1 second, guys. Some important call is coming. Yeah, sorry guys for so much of interruption, but usually in our conceptual video there will not be any interruption, but this is a question only, and mostly those guys who are preparing for interview, they are watching this video, so you guys already know the concept now. Most of the things you need to do on your own. Whatever that you don't know, that I am teaching here, nothing else. So I guess taking a break will not break the consistency, but when it comes to our course video, we will not give these much of a interruption in between. But in those kind of videos, if the interruptions are there, I don't think it will be a big matter of concern, right? So here, what will be the voltage drop at steady state? No current is flowing, so this voltage drop will be 0 ampere. So there will be 0 voltage drop. So VC2 will come down to 0 only. VC2 will come down to 0 volt only. And what about VC1? Here there is 5 volt. Since there is 0 voltage drop, so this 3 volt will come here. This will be 3 volt. So 5 in this direction, 3 in this direction. This will be 2 volt. And what about V0 infinity? That will also be 3 volt. That's it. Okay. So what is the waveform you are getting? VC1 is coming down to 2 volt, from 3 to 2 volt. 3 to exponential 3 to 2 volt it is coming. Then this is going from 1 to 0, 1 to 0. This is your 2 volt. This is going from 1 to 0. And what about V0? This is going from 2 to 3 volt. That's it. This is the complete answer. Okay. If you feel like that, sir, I was lagging in these kind of concepts, sir, switch capacitor concept, I don't know, sir, what is delta V, then you need to watch the video of switch capacitor. So please study transient analysis before your interview, because people would think that, sir, network analysis is very easy, I will skip it. I will simply go to analog electronics. Network analysis is the basic subject, and 9 out of 10 students are rejected just on network analysis. Not even in the MS Tech interview. I am talking about the industry interview as well. When you sit for placement, so people will say network analysis is very easy. I know this, I know that, and they will struggle in these kind of questions. And you will be rejected right here. Although this is a good question, I can reject you even before these kind of questions. So please follow the lectures. I know you have studied from good educators, but try studying from human beings as well, because human beings will help you more. Okay. So these kind of questions are pretty good, and I hope you are good enough to understand these kind of problems now. Okay. So switch capacitor and all, everything is used here. To be very honest, this question is pretty good, but these were there in our test series. If you just solve our test series and if you just watch our lectures, there wouldn't be a single question which you will be missing out. Whether it is network analysis, analog electronics, signal system, control system, engineering mathematics, or EMFT, communication, power electronics, everything we have covered. Okay, when we teach for everything that is required at UG PG level, at least at the entrance level of PG. Okay, yeah. I hope it is good enough for you. Yeah, thank you very much. Happy learning. You can comment down how you felt for this particular video. Yeah, thank you.